Hi class, welcome to our first video lesson on 7-3. It's kind of like 7-3 day 1. We're talking special right triangles in 7-3, and this specifically is the 45-45-90 special right triangle. The reason why we talk about this, the way we derive it, it comes from the square. Let's list everything that we know about a square. Hopefully something that you were taught at a very young age is that a square has 4 congruent sides. All 4 sides are the exact same length. So you could put tick marks at all of these. If one side is 3 feet, they're all 3 feet. If one side is 12 miles, they're all 12 miles. Hopefully another thing that you know about a square is that each angle is a right angle, or each angle is 90 degrees. So it has 4 right angles. So here's where the 45-45-90 comes into play now. If you could, please draw this diagonal in your notes right here. There it comes. So what this does is it splits the square up into 2 triangles. And these 2 triangles are right triangles. So there's the blue one that I'm going to have. Now we just said that this leg is congruent to this leg, right? In all 4 sides of a square. So then these 2 of the triangle would be congruent. And this side right here would be the hypotenuse. It's the longest side. Of course, the diagonal would be longer than the 2 legs. So it's the longest side. And we're going to notice the relationship about that longest side. But of course, the hypotenuse comes opposite the 90-degree angle. Now, what we're going to find here is that the hypotenuse is always the longest, and it's bigger by a certain number. It's always bigger by the square root of 2 times as much. So if you have one of these legs, let's say this leg is 7 feet. This would, of course, also be 7 feet. They're opposite of the 45-degree angles. Notice the 90-degree angles in the corner. Well, if we put a diagonal and cut it in half, they're 45-degree angles. So opposite the 45-degree angles, if the angles are congruent, then the sides are also congruent. So really, a 45-45-90 is also an isosceles triangle. The 45-degree angles are base angles. And then the hypotenuse is always longer, and it's always longer by the square root of 2 units. So if this was 7, the hypotenuse would be 7 multiplied by the square root of 2. If this was 17 feet, this was 17 feet, the hypotenuse would be 17 multiplied by the square root of 2 feet. So that's the relationship with the 45-45-90. It's a quick shortcut. We could do the Pythagorean theorem, a squared plus b squared equals c squared. It just is a lot easier to say, well, if we have the legs, to get to the hypotenuse, we multiply by the square root of 2. Now in the exact opposite way, if we have the hypotenuse, and we need to get to the legs of a 45-45-90, if we know that this is 12 meters, we could easily get to the legs. This time, instead of multiplying by the square root of 2, we would divide by the square root of 2. Or to get to this leg, of course, we would divide by the square root of 2. So bottom line, if you have the legs and you want to find the hypotenuse, multiply by the square root of 2. If you have the hypotenuse and you want to find the legs, you divide by the square root of 2. So that's what we're going to write down here. This is going to be like our cheat sheet. If this side is x, this side has to be the same thing. They're opposite the 45-degree angles. So x is like our variable. If one side is 7, the other side is 7. If one side is 12, then this side is 12. If one side we call x, then the other side is also going to be x. And then our hypotenuse is the side multiplied by the square root of 2. It's the square root of 2 times bigger. And that's what we're going to use for these 6 problems here coming up in our notes. So for the first one, I'm actually going to solve for all parts of the triangle. We'll call this y, if you want to write that in your notes as well. We know this is a 45-45-90 degree right triangle because it tells us this is 90. If this is 45, then there's only 45 degrees left in the triangle, so it's a 45-45-90. So this and this would be the legs, and the legs are always congruent. So y also equals 3. Opposite the 45-degree angles are the 2 congruent legs, so they're both 3. And then x is bigger by the square root of 2 units. So to get to the hypotenuse, you take 3 and you multiply it by the square root of 2. It's that basic. If you do have the leg, you can solve for the hypotenuse by multiplying by the square root of 2. Same thing here for question number 2. We have a 45, 45, 90 degree right triangle. So opposite the 45s are the two legs, and they are congruent. So once again, let's write down y equals 6. This leg is 6 units long. The hypotenuse is the square root of 2 times the legs. So x is the leg, 6, multiplied by the square root of 2. And that is our answer. For question number 3, this time we don't have the legs. We have the hypotenuse. So if we have the hypotenuse, we could easily find the leg. This time, instead of multiplying by the square root of 2, we're going to divide by the square root of 2. So I'll put y right there, and x and y are going to end up being the exact same thing, right? Because they're the two legs of the 45, 45, 90, and the two legs will always be congruent. So x and y, for that matter, are going to be the hypotenuse divided by the square root of 2. If you have the legs, you multiply by root 2 to get to the hypotenuse. If you have the hypotenuse, you divide by root 2 to get to the legs. I wish I could tell you that this is your answer, class. However, mathematicians are kind of picky about not having radicals in the denominator. So let's rationalize the denominator. The way you do that is you multiply by root 2, because root 2 times root 2 is 2, and now you don't have a radical in your denominator anymore. If you do that to the denominator, you sure had better do that to the numerator to make the equivalent fraction. So 4 times root 2 is 4 root 2. So then our answer, we could reduce 4 halves is the same thing as 2. So x equals 2 times the square root of 2. And that's this leg, and this leg is the same because they're both opposite the 45 degree angles. They're the congruent legs in an isosceles triangle. So y also equals 2 square root 2. Question number 4, again, we have the hypotenuse. So if we have the hypotenuse, if we want to get to the legs of a 45, 45, 90, we simply divide by the square root of 2. So x and y is the hypotenuse, 3 root 2, divided by the square root of 2. If we have the legs, we multiply by root 2 to get to the hypotenuse. If you have the hypotenuse, you divide by root 2 to get to the legs. So we could rationalize this by multiplying both top and bottom by root 2, or we could just identify, well, anything divided by itself is 1. It kind of cancels out. So root 2 divided by root 2 makes 1. So y equals 3. 3 root 2 divided by root 2 is just the number 3. I don't know why I said y. X. And y is also the same thing because, again, these are the two legs of the isosceles 45, 45, 90 degree triangle. So there is x and y. They're both 3. All right, what happens if you don't have a picture? I would say draw a picture. It tells us it's a triangle, triangle ABC. The problem tells us that A is a right angle, and it tells us angle B is 45 degrees. Well, if I draw a triangle, and it has to be a right triangle, and if A is 45 degrees, if A is 90, or a right angle, and B is 45 degrees, again, if you subtract 180 minus 45 minus 90, the other one also has to be 45. So we're dealing with a 45, 45, 90 degree right triangle. If AB is 44, so from here to here is 44, that is one of the legs. The other leg is AC. It's also 44. And that means the hypotenuse is BC, and that has to be bigger than the legs by the square root of 2 units. So this hypotenuse is 44 multiplied by the square root of 2. And that's what our answer is here. It says find the length of BC. Well, BC equals 44 multiplied by square root 2. And our last one for the day. Tristan has a square backyard with an area of 225 square feet. He started to plant, but only did half of his yard. What is the perimeter of the grass section of the backyard? So it says he only did half. However, he didn't do this half, right? Instead, he made the diagonal. So it's going to be a 45, 45, 90 right triangle. So what we need to know here, class, is we need to know some length about the triangle. If we know that the area is 225, we'll get to this a little bit later, but I'll kind of give you a hint right now. Maybe you've had it before. If the area is 225, the area of a square is length times width. And the length and the width are the same. So in a way, it's kind of like the area is equal to the side squared. So if 225 equals the side squared, you can just square it 225, and then you get the length of each side. So the square root of 225 is 15. So this is 15, this is 15, this is 15, and this is 15. And we want to know what is the perimeter of the grass section. So here is our grass section. So it's 15 plus 15 plus the hypotenuse. And what's the hypotenuse? It is the square root of 2 bigger than the legs. So it's 15 root 2. So our perimeter of the grass is 15 plus 15 plus 15 root 2. Or our perimeter is 30 plus 15 root 2. And this is in, the perimeter is in square feet, or the area is in square feet, so the perimeter would be feet. Hopefully that made sense. If you have any questions, be sure to let me know when you get to class tomorrow.